So now that we know how to use the universal law of gravitation to think about the gravitational interaction between point masses, we want to see how our new way of thinking about the gravitational force impacts the gravitational potential energy. So when we first introduced gravitational potential energy towards the beginning of the semester, we were talking about the gravitational potential energy in a constant field, specifically in the constant field at or near the surface of the Earth. We took our definition for the work done by a constant force, where it's the magnitude of the force times the magnitude of the displacement times the cosine of some angle between those two vectors, and our definition for the potential energy that told us that the change in the potential energy was equal to negative the work done by some conservative force, and we built those together to get an equation that told us how the gravitational potential energy changes in a constant gravitational field. So it's going to be plus or minus the mass of your object times the strength of the gravitational field times delta H, the distance that your object moves up or down. And mg and delta H were all defined to be positive, so whether the gravitational potential energy was increasing or decreasing had to do with whether or not we needed the plus or minus sign out front. How was it that we determined when the gravitational potential energy was increasing or decreasing? Well, our question was, is the object moving up or down? So if we had an object sitting in the Earth's gravitational field, gravitational force is going to point downwards on that object, but if I let the object move up or down, then the gravitational potential energy increased if the object moved up. I needed my plus sign, and it decreased when the object moved down. I needed the minus. Now the gravitational force, of course, it always pointed down. There's another way that we can reframe thinking about whether or not the gravitational potential energy was increasing or decreasing, and it's thinking about whether or not your object was moving with or against the gravitational force. So if the gravitational force points down, when your object moved up, it was clearly moving against the gravitational force, and so the gravitational potential energy increased. On the other hand, in moving down, the object was moving with the gravitational force, which also pointed down, and the gravitational potential energy decreased. So if we want to think about the gravitational potential energy and how it changes as some mass moves in the gravitational field created by point masses, then whether or not the object's moving up or down is probably not going to be a good enough question. But the way that we're talking over here on the left gives us a pretty good idea about how we need to adjust and come up with a better question here. And so instead of asking, is the object moving up or down, it looks like what we want to ask is the object moving with or against the gravitational force? If your object is moving with the gravitational force, then the gravitational potential energy will decrease. If the object is moving against the gravitational force, then the gravitational potential energy will increase. And of course, we said that this is true for any potential energy. Whether or not any potential energy is increasing or decreasing is a statement of whether your object is moving with or against the conservative force. So we want to reframe thinking about how the gravitational potential energy changes now that we're dealing with point particles, and think in terms of the change in the gravitational potential energy of a mass as it moves in the presence of other masses. That indicates whether that mass is moving with or against the net gravitational force that's acting on it. What is it that causes the gravitational potential energy of some mass to increase? Well, I know that if the gravitational potential energy has increased, then the mass has moved against the gravitational force, which means that the work done by gravity must have been negative, and this negative work term will cancel out the minus sign sitting out in front. But that's only possible because you or some other external agent had to do positive work on that mass to move it against the net gravitational force. So how the gravitational potential energy of some mass is changing is entirely a function of whether that mass is moving with or against the gravitational force.